This chapter we get to discuss percents. Now a percent is a ratio that compares a number to 100. Percent. A century is 100 years. A cent is 100th of a dollar. It's literally the prefix you can use for hundredths. So percent is like per 100. So it compares a number to 100. Yeah, it's pretty obvious where the term came from. Now to write a fraction as a percent, find an equivalent fraction with a denominator of 100. If the denominator is a factor of 100, you can use mental math. In other words, multiply as needed. Examples. Write each ratio or fraction as a percent. Bob made 55 out of 100 free throws. Ooh, he's pretty good, at least compared to me. Yeah. So this is equal to 55%. I recommend using the circles for percent instead of dots because dots are easier to misinterpret, whether accidentally or maliciously. 3/5 of all high school students are not taking physics. Whoa, that's a lot of high school students taking physics. So 3/5, that's 3 over 5, which is equal to how many over 100? Oh, you multiply the denominator by 20, so you must multiply the numerator by 20 as well. So 60 over 100. So 60 over 100 is 60%. You can express a percent as a fraction by writing it with denominator 100. Then you write the fraction in simplest form. Like let's say we write 45% as a fraction in simplest form. Well, 45 over 100, we notice that the top and bottom are both divisible by 5. Which gives us 9 over 20, and there's no common factors left, so that's it. That's the simplest form. Although, honestly, we should start with 45% is equal to 45 over 100, because this way we show all our steps, and yeah, teachers, at least at the beginning, when you're doing a type of problem, they like you showing all the steps. Exercises. Write each ratio or fraction as a percent. 29 out of 100. Well, it's already out of 100, so it's 29%. 4 to 5 is equal to 4/5, which is equal to how many over 100? It's equal to 80 over 100. So it's equal to 80%. 11 to 50, well, that's 11 over 50, which is equal to 22 over 100. Denominator and numerator both are multiplied by 2. So it's 22%. 33 over 25, oh hey. You multiply 25 by 4 to get 100. And then on top, 33 times 4, we get 132. So that means it's 132%. Now let's say we want to write each of these percents as fractions in simplest form. 27%. Well, that's 27 over 100. And there are no common factors. Therefore, we leave it as is. 15%, that's 15 over 100. The common factor is, well, the greatest common factor. You got 3 times 5, and on the bottom you got 2 times 2 times 5 times 5. So the greatest common factor is 5. So that you divide both the numerator and denominator by it, and you get 3 over 20. 60% is 60 over 100. Yeah, we can immediately get rid of a 0. So this leaves us 6 over 10 is equal to 3 over 5. Because we can divide both top and bottom by 2. 84% is equal to 84 over 100. Now we notice that the top and bottom are both divisible by 4. So we do that, and we get 21 over 25. 3 times 7 versus 5 times 5, no more common factors more than 1. So it's in simplest form. Let's say we need to compare decimals, fractions, and percents. Well, to write a percent as a decimal, you divide by 100 and remove the percent symbol. To write a decimal as a percent, you multiply by 100 and add the percent symbol. Look, there's a reason why this conversion is literally times 100%. It's because 1 is equal to 100%, and by multiplying by 100%, what you're doing is multiplying by 100 over 100. So in other words, multiplying by 1. To express a fraction as a percent, you can use a proportion. Alternatively, you can write the fraction as a decimal and then express the decimal as a percent. Use a proportion basically means you can convert the fraction so that the denominator is 100. Yeah. So, all this stuff in text, how do you remember this quickly? 1 is equal to 100 over 100 equals 100%. Or 1.00 equals this. That works too. Now, write 52% as a decimal. 52% is equal to 0.52. It's 52 parts out of 100. So divide by 100 means you move the decimal point 2 places to the left. Yeah. So write 0.37 as a percent. Well, 0.37, you can think of it as multiplied by 100% if you like. Or you can just mental math it and be 37%. This part here, in my experience, this multiplied by 100%, in my experience, teachers tend to ask for it the first few times you do a type of problem, and eventually they stop asking for it. Because it's showing what you thought of. It's not like, oh, I just guessed it equals 37%. Like this shows your thought process. Write 9 over 20 as a percent. Well, 9 over 20 is equal to, to get the denominator to 100, we multiply by 5, and the numerator, 5 times 9 is 45. So it equals 45 over 100, or 45%. All right. Exercises. Write each percent as a decimal. 12%. Well, we know that 100% is 1.00. So 12% is 0.12. 76% is 0.76. You can say that we divided it by 100% if you like. 42.37%. Well, we know that 100% is 1, so 42% must be 0.42. And the 37 just come at the end. Because if you think of it as dividing by 100%, you move the decimal place 2 places to the left, as you do when you divide by 100, and the percent signs cancel out. Write each decimal as a percent. 0.18. Well, this is equal to 1 is 100%, so 0.18 is 18 parts out of 100, 18%. 0.925. You can go times 100% if you like, but it's going to end up being 92.5%. 1.27. Well, 1 is 100%, so 1.27 is going to be 127%. Let's say we want to write these fractions as percents. 3 over 4. Well, 3 over 4 is equal to how many over 100? It's equal to 75 over 100. So it's 75%. 9 over 8 is equal to, 8 has to be multiplied by 12.5 to give us 100. 9 times that is going to be 112.5. So it's 112.5%. Yes, you can have decimals in fractions. So 23 over 40, well, 40 times 2.5 is 100. So 23 times 2.5 would give us, well, okay, 23, you go to 46, that's the times 2 part, and then you got 11.5. So 57.5. Alternatively, you could have broken it up into the 20 and the 3, which would have been faster. 20 times 2.5 is 50. Okay, 3 times 2.5 is 7.5. Done. So, this is 57.5%. Now, percent proportions. You can use percent proportions to find a missing part, whole, or percent. The part divided by the whole is equal to the percent. So 15, the part, is what percent of 60, which is the whole? Well, part over whole is equal to percent. And so we get 15 over 60 is equal to what? Well, 15 is 1/4 of 60, and 1/4 is 25%. As anybody who has used quarters, as in the coin for 25 cents, can tell you. There's a reason they're nicknamed quarters. So what number is 40% of 43? Well, let the number be n. N over 43, so it's 40% or 0.4. So n is equal to 0.40 times 43, which is 0.4 times 43, 17.2. That's n. All right, let's do some exercises. Write a percent proportion and solve each problem. Round to the nearest tenth if necessary. Let unknown be n. Okay? 3 is what percent of 10? 3 over 10 is equal to n. N is equal to 30%. Okay. Yeah, 3 over 10, that's 30 over 100, so 30% we go. So what number is 15% of 80? N over 80 is equal to 15%. N is equal to 0.15 times 80, which is equal to 12. 0.1 times 80 is 8. 0.15, so half again that much, that's 12. Now what number is 62.5% of 120? So n over 120 is equal to 62.5%. N is equal to 0.625 times 120, which is equal to, hey, what's 0.625? 0.125 is 1/8. So 0.125 plus 1/2 is 1/8 plus 1/2. So that's 5/8. What's 1/8 of 120? 1/8 of 120 is 15. 5/8 times 120 should therefore be 75. So n is equal to 75. 52 is 26% of what number? Well, that means 52 over n is equal to 26%. N is therefore equal to 52 divided by 0.26. So n is equal to 200. Yeah, given that 52 is 2 times 26, this is a number that you could have solved without much formulaic work. On the other hand, 161 is 73% of what numbers? This is a bit more awkward. This, yeah, you should probably use a calculator for. Equals 73%. And that means n is equal to 161 over 0.73. So n is equal to 0.73. 220 point. There are some additional numbers here. What does that mean? Well, we got 220. And then you got, out of 73, you have 16100 minus 220 times 73. So what's 220 times 73? Oh, that's 16060. So it's 220 and 16100 minus 16060 over 73, which leaves us at 220 and 40 over 73. That's the value of n, the number. Okay then, 48 is what percent of 66? Well, 48 over 66 is equal to n. n should be a fraction or a decimal, really. Like, if you were just given this number without specifying percent, you would probably find a fraction or give it as a decimal, even though giving it as a decimal results in repeating. So yeah, it's probably going to be expressed as a fraction normally, but it says what percent of 66. So we have to convert that fraction into a percent. N is equal to 48 over 66. The decimal you get is going to be 0.72 repeating. These two digits repeat themselves. But when you're converting to a percentage, you get 72 and then 0.72, and then you say the decimals repeat themselves. Percent. It is also possible to give it in the form of, over here, another fraction, then a percent symbol. So you can have a mixed fraction and then a percent symbol. That's okay. But for the most part, you usually just go with decimals. Finding percent mentally. Mental math OP, please nerf. So, to find 1% of a number mentally, move the decimal point 2 places to the left. To find 10% of a number mentally, it's 1/10, so you move the decimal point 1 place to the left. Unfortunately for everybody involved, the math curriculum in North America generally does, in fact, nerf mental math by introducing kids to calculators way too early and not enforcing enough practice on them to find hundredths or tenths very, very easily and basically instinctively. So find 1% of 197. Well, that's 100th as much, so divide by 100. 1% times 197 is equal to 1.97. Find 10% of 3.2, that's divided by 10, so 3.2 times 10% is equal to 0.32. Now, when you compute with common percents like 50% or 25%, it can be easier to use the fraction form of the percent. It is a good idea to be familiar with the fraction form of some of the common percents, like 1/8 is equal to 12.5%. 1/4 is 25%. And you see, like 37.5, that's just these added together, which means it's 3/8. 62.5, well, that's this plus 1/2, which is 50%. So 50% plus 12.5%, that's 62.5%. That's 5/8. 7/8, that's 100% minus 12.5%, so 87.5%. 3/4, 75%. And then you got stuff like 1/5 is equal to 20%. 1/3 is equal to 33.3 repeating percent. Or, alternatively, you can have it as 33 1/3, like shown here. 1/6 is 16 2/3, or 16.6 repeating percent. Right. And then, of course, there's 1/10, 1/20th, 1/25th. Yeah. So those are pretty straightforward. Find 25% of 68. 25% times 68 is 1/4 of 68. 60 divided by 4 gives you 15. And then 8 divided by 4 gives you 2. So 17. Yeah, you could also have gone divide by 2, which would have given you 34 and then 17. Find 33 and 1/3% of 57. 33 and 1/3% times 57. That's 1/3 of 57, which should give you 19. Because 60 divided by 3 is 20, and 57 is 3 less. So you end up with 19. Let's do some exercises. Compute mentally. 40% of 45. Well, that's 40% times 45. What's 40%? Oh, it's 2/5. What's 1/5 of 45? 45 divided by 5 is 9. So 2/5 is going to be 2 times 9. So we're looking at 2 by 9 equals 18. Yeah, we're just going to equal straight off of the word expression, guys. Save ourselves some time and less of you staring at me scribbling on the board. 50% of 38. 50% is 1/2. So half of 38 is 19. 1% of 212. 1% is 1 over 100. So 1 over 100 times 212. Or just 212 divided by 100. What happens? Oh, we move the decimal places. And we end up with 2.12 because it's dividing by 100. 30% of 70. Well, that's going to be 0.3 times 70. Or you can go, oh, 10% of 70 is 7, therefore 3 times 7 is 21. 33 and 1/3% of 93, that's going to be 1/3 of 93. 1/3 of 93 is 31. 75% of 36, that's 3/4 of 36. So, what's 1/4 of 36? It's 9. 9 times 4 is 36. So, 3/4 is 3 times 9, or 27. The obligatory problem-solving section. Reasonable answers. See, when you have your 4-step problem-solving plan, there is a possible estimate involved. And what else? Well, there's also see if it seems reasonable. Now, usually these two things actually kind of are interconvertible, because if you made an estimate, well, you can immediately see if it seems reasonable. If you didn't, well, this is when you make your estimate to see if it seems reasonable. Let's say we have the cost of a guitar being $300. Margaret works at the music store and can buy the guitar for 65% of the price. Will she have to pay more or less than $200? Well, I got a question, guys. Do we have sales tax involved? Yeah, no, okay. So, jokes aside, the cost of the guitar is $300. She can buy it for 65% of the price. 65% of $300. Okay? So 65% is less than 2/3. or 66.6 repeating percent. Versus $200. $200 is 2/3 of $300. So 65% of $300 is less than $200. Okay? Because, well, it's less than 2/3 of $300, and 2/3 of $300 is 200. So yeah. Let's say somebody gets paid $14 an hour to work at the bookstore. If she's saving to buy a new game system that costs $449.99, consoles. PC Master Race. Anyway, will she have to work 30, 40, or 50 hours? Look, $14 times 30 is 420, okay? Which is not enough. 14 times 40 is 560. Considering the deductions that come out of your paycheck before it reaches you, yeah, it's probably going to be 40 hours. She has to work 40 hours to get this game system. I mean, in theory, she can get it at a little over 32 hours worked. In practice, no. So, theory, just over 32 hours. 32 hours would get her $448. Needed. In practice, she's probably got to work. She's got to work 40 hours. Yeah, okay. So suppose you brought $140 and you buy a coat for $56.99. You want to purchase a pair of jeans for $28.99, okay, and a pair of boots for $54.99. Do you have enough money to make these two purchases? Well, total price is approximately 57 plus 29 plus 55. Which is, yeah, you're going to end up with a 1 at the end. And 2 carried, so you're going to end up at $141. Because for each of these we only rounded up by 1 cent, we're a whole dollar over with our estimation, and we're only 3 cents back from that estimation value. So it's approximately this. It's actually equal to 140.97. So you brought $140. No. You need 97 cents more. And that's assuming, by the way, that these prices are after tax. Because sales tax is a big deal. In a recent survey, 55% of students at a high school work at part-time jobs during the school year. If there are 1,297 students in the school, is 600, 700, or 800 a reasonable estimate for the number of students who work part-time during the school year? Well, we're looking at approx 1,300 students. 1,300 students. 55% by 1,300. Look, 50% times 1,300 is 650. So 55% by 1,300 has got to be 650 plus 65, or 715. So 700 is a reasonable estimate. Oh, estimate. Okay. Byron took $80 to the mall to buy gifts. He spent $29.99 on a video game. Typical pricing policies to make the number look smaller. He wants to purchase a book for $9.99 and a laptop bag for $39.99. Does he have enough money with him to make these two purchases? Let's see. Total price. Total price is approximately $30 plus 10 plus 40, which means that it's approximately $80. But we know that it's actually equal to $80 minus 3 cents. $79.97. So yeah, he has enough money. Has enough money, in theory. But I'm not going to write that on the board. So in theory, he has enough money, but then again, there's the, what taxes do you have in your area, and are those already included in the price problem? There are 1,200 students at a high school. If 43% of the students attended an exhibit given by the art department, would the number of students who attended be 924, 516, or 430? Guys, there are 1,200 students. 1,200 times 40% is equal to 480 students. And the other 3% times 1,200, that's equal to 3 times 12, or 36. So 1,200 times 3% is equal to 36. Sum equals 516. So, yeah. The number attending would be 516. Yeah, you may want to go 1,200 times 40% plus 3% equals this instead, but, well, the point is communicated. Percent estimation. You can use compatible numbers, in other words, numbers that are easily to multiply or divide mentally, to estimate a percent of a number. So let's say we estimate 45% of 60. Well, 45% times 60 is equal to, guys, 45% is 9 over 20. Okay, times 60. You're canceling. And you end up with 3 by 9 is 27. What else could you have done? You could have gone, oh, it's 50% times 60 minus 5% times 60. So next we have example 2. Estimate what percent corresponds to 25 out of 62. 25 over 62 is approximately 25 over 62.5. Now, 62.5 is 5 times 12.5. And 25 is 2 times 12.5. Do you see where this is going? We can cancel these and we get 2/5 approximately. So it's approximately 40%. Okay? Right. Exercises. Estimate 12% of 64. Well, it's approximately equal to 12.5% times 64. And we know that 12.5% is 1/8. So 1/8 times 64 is 64 divided by 8 equals 8. It's approximately 8. 24% of 37 is approximately 25% of 36. 36 is a multiple of 4, and 25% is 1/4. So, a quarter of 36? 36 divided by 4, that's 9. Approximately. Because we made approximations. 32% of 66 is approximately 33 1/3% of 66. So we're looking for 1/3 of 66, or 22 approximately. Yeah, it said estimate, so we're doing some rounding. 67% of 44. Well, that's approximately 66 2/3%. So it's 2/3 of 45, approximately. This will give you approximately 30. So estimate each percent. 7 out of 15. 7 out of 15 is approximately 50%. I mean, it's a pretty rough approximation because 7.5 is an appreciable distance from 7 when it's out of 15. Because 0.5 over 15, that's 1 over 30, or 3.3, so 3 1/3%. 6 out of 23 is approximately 6 over 24. Therefore, it's approximately 1/4 or 25%. It is actually an appreciably bigger percentage than that, but 6 out of 23 is close enough to 25%. That for our estimation purposes, for now we can leave it at that. 13 out of 19. Well, that's approximately equal to 12 out of 18. And those are convenient numbers because they give you 2/3, or 66 and 2/3%. Now 19 out of 26. Well, you can go for 18 out of 27, or you can go for 20 out of 25. There is a problem. Both of those will be appreciably off. But you know what? You can also go for 18 out of 25. As long as both numbers are reasonably large and you're not too close to 1, then you can subtract 1 from both numerator and denominator without much issue. So, why is this still okay for an approximation? It's because divided by 25 is equal to times 4%. 1 over 25 is 4%, so 18 over 25 is gonna be 18 times 4. 18 times 2 is 36, and times 2 again is 72%. Yeah, because going for 18 out of 27, which is 2/3, you'd be rounding the numbers in opposite directions, which tends to produce a pretty big rounding error. Going for 20 out of 25, once again, you're going to end up with a pretty big rounding error. Whereas the actual number, 19 divided by 26, is, 0.730769, and so on. Yeah, it's pretty close to this one that we got, which was 72%. Percent equations. These are equivalent forms of percent proportions, and we write this with the percent written as a decimal. Or alternatively, you can just write the percent with the percent symbol attached, which tells you that you can, instead of multiplying by 50, you're multiplying by 50 out of 100, which is, of course, pretty different as an outcome, just as an example. So part equals percent times whole. Find 24% of 255. The part is equal to 24% times 255. Now this, you can convert it to 0.24 if you like. Or you can leave this step out and go straight to the answer, as long as you entered it correctly on your calculator instead of doing 24 times 255. 0.24 times 255 is equal to 61.2. Yeah, if you want to notice that you did not convert your percents to decimals properly, the most obvious sign is that you are a couple orders of magnitude off. In other words, you went 24 by 255 and you ended up, wait a second, about a quarter of 255, or about a quarter of 250 is not supposed to give me a huge number. It's not going to give you 6,000 something. 615 is what percent of 750? Well, 615 is equal to, let this be n, so the unknown. We write n as a decimal at first, and then we convert to percent later. So, 615 over 750 is equal to n. What happens when we divide both numerator and denominator by 15? Well, 615 divided by 15 is equal to 41. And 750 divided by 15 is equal to 50. 41 over 50 is, yeah, we can give it as 0.82, but in this case, we're just going straight to the percent, which is 82%. All right. 45 is 90% of what number? Yeah, okay, it's pretty obvious. 45 is 90%, or 0.9 of 50. Okay. So we let this number, this unknown, be n, and then 45 is equal to 90% times n. N is equal to 45 divided by 0.9, so n is equal to 50. This is just the same old rearrangement of the formula that we dealt with earlier. But North American math textbooks insist on teaching you like a dozen different formulas that are all actually the same, just so that you have a hard time learning any of them. Well, you just gotta deal with the fact that this type of problem can be given to you and you're expected to solve it in this way. That doesn't mean, however, you can't solve it in this way by starting with the one formula you bothered with that's actually can be changed to give different formulas and rearranging. Like you only have to memorize actually a few mathematical formulas. Solve each problem using the percent equation. Find 30% of 70. Well, let unknowns be n. Okay, so n is equal to 30% times 70. Fine. That's what? 0.3 times 70, so 7 times 3, or 3 times 7, 21. Okay. What is 60% of 55? N is equal to 60% times 55. So 0.6 times 55, or 6 times 5.5, that's 33. 50 is 40% of what number? Well, 50 is equal to 40% of n. N is therefore equal to 50 divided by 0.4. Well, 0.40 if you insist that this digit is not just a placeholder and that it actually contains information, which tells you that 40% is an approximation to the nearest percent instead of the nearest 10%. This is important in, say, physics, for example, and is why scientific notation is so important. It tells you what the significant digit number is. So 50 divided by 0.4. What does that mean? Oh, 50 divided by 2 over 5. In other words, 50 multiplied by 5 over 2. Okay, then. That's 25 times 5, so 125. So, n is equal to 125. 55% of what number is 77? 77 is equal to 55% of n. So, n is equal to 77 over 0.55. So, this is equivalent to 70 divided by 0.5, which gives us 140 for n. Now, what percent of 2,000 is 24? Well, 24 is equal to n times 2,000. Okay then, n is equal to 24 over 2,000. Or 12 over 1,000. So 12 over 1,000 is going to be 1.2%. 12, 1,000. And this is equal to n. Because 12 over 1,000 is equal to 1.2 over 100. Yeah, just in case that's an issue. What is 191% of 80? N is equal to 191% times 80. So it's equal to 1.91 times 80, which leaves you with 1.91 times 80, 152.8 is the value of n. To find the percent by which something changed, you find how much it has changed, and then you find the ratio of that amount to the original amount. In other words, if you have 10 things at the beginning and then you have 15 at the end, you increase by 5. Compared to your initial 10, that's 5 over 10, or 50% increase. Example, 2 months ago, the bicycle shop sold 50 bicycles. Last month, 55 bicycles were sold. Find the percent of change. State whether the percent of change is an increase or a decrease. Well, 55 minus 50 over 50. New data minus old data divided by old data is equal to the percent of change. In this case, it's going to be 5 over 50, which is 1/10, and yeah, it's 10%. Specifically, it's positive 10%. This is an increase because it ended up being positive when you use the new minus old over old. Yeah, well, I should probably write that down. Yeah, okay. It also just makes sense when we look at it because we went from 50 up to 55. Therefore, it's got to be an increase. Oh, it was an increase of 10% or positive 10% change? Okay, that makes sense. Exercises. Find each percent of change. Round to the nearest tenth of a percent if necessary. State whether the percent of change is an increase or a decrease. So, new minus old over old. That means 5 minus 4 over 4 is equal to 1 over 4. So it equals positive 25%. Yeah, it's an increase. Now, new minus old, going from 10 up to 17 is obviously plus 70%, but mathematically we express it as 17 minus 10 over 10. New minus old over old, which is equal to 7 over 10 equals plus 70%. This is an increase. Increase of 70%, you could say, in a statement. Now let's say we go from 15 up to 18. Well, we go, the difference is positive 3, and divided by the original, that's 3 over 15, which is equal to 1/5. And that's 20% increase. Original 30, new 22.5. 22.5 is the new minus the old. So you end up with negative 7.5. And it's going to be negative 7.5 over 30. So negative 1/4, or negative 25%. Or you could state this as decrease of 25%. Like, what's your percent of change? Negative 25%. Or a decrease of 25%. Going from 60 down to 51, we get new minus old over old, which is going to be negative 9 over 60. So, we got negative 3 over 20, or negative 15%. Right, you could say that this is a decrease of 15%. And if you had, say, 140 down to 112, well, that's obviously going to be a negative change over the original amount. So, hey, it happens to be negative 28 over 140. In other words, negative 1/5, or negative 20%. And this would be decrease of 20%. So, when you state an increase or decrease of some percentage, you're going to state it as a positive percentage. But if you're just stating the percent of change as a number, you need positive or negative signs attached. That will indicate the direction of the change. Simple interest is interest that's calculated based off of your principal amount, the amount of money that's been invested or borrowed. So the original initial amount. Compound interest, unlike simple interest is additive. Like, you plot it on a graph and you will find that it's your principal amount stays the same, but your interest builds up as a straight line. Compound interest, on the other hand, will increase exponentially, i.e., the interest from previous periods is used to calculate, like as part of the principal, to calculate the interest for the next period. Simple interest, you just calculate based off of the initial principal. Now let's say we find the simple interest for $600 principal. By the way, principal can be spelled either way depending on convention. Invested at 5.5% for 6 months. Unless otherwise stated, the interest rate is given as an annual interest rate, so per year. Time t is the time in years. In this case, the formula gives us interest is equal to principal, rate, and time multiplied together. The principal is $600. The rate is 5.5%, and the time is 6 months, which is going to be 6 over 12. So half a year. So 600 times 0.055 times 1/2. What else could you have done? Actually, you could have canceled the 100, so the 2 zeros, with the percent symbol. So you could have done 6 times 5.5 divided by 2. So, Overall, this whole thing multiplies out to $16.5. But because it's dollars, sometimes you're supposed to write the dollar sign in front, although most teachers don't actually care if you write it at the back. And you're supposed to have all the cents included as long as you don't have a whole dollar amount. So the simple interest would be $16.50. That would be your statement. Example 2. Find the total amount in an account where $144 is invested at 7.5% for 2 years. Well, the interest would be principal times rate times time. Principal is $144. And the rate is 7.5%, which, by the way, for an annual interest rate is pretty high, at least compared to saving accounts. For 2 years, so time is 2. Okay, then 2 times 0.075, because that's what 7.5% is. Oh, that's 0.15. Okay, as expected. Nothing's wrong with the calculator. Times 144. $21.6. Okay, so 60. Total equals principal plus interest. In other words, 144 plus 21.60, which is equal to $165.60. All right then. Let's find the simple interest to the nearest cent. $400 at 5% for 2 years. Well, the interest is equal to principal times rate times time. So principal is 400, rate is 5%, and it's for 2 years. So you can cross out the percent symbol and 2 of the zeros. 4 times 5 times 2, or rather 4 times 10 is $40. $650 at 6% for 3 years. It's just interest equals principal, the amount you deposited or loaned, and interest rate and time. Make sure to convert the time appropriately to the units for your interest rate. Unless otherwise stated, the interest rate is generally given as per annum, so per year. So principal is $650, rate is 6%, and time is 3 years. So we're looking at 6.5 times 6 times 3, $117. Because you can cancel out the percent by 100. 6% is 0.06. All right, $1,555 at 6.7% for 3 years. Now it's to the nearest cent, so interest is equal to principal, 1,555, times the rate, 6.7%, times the time. Well, that was percent per year, so we multiply by number of years. 6.7%, 0.067, times 3 times 1,555. So this is equal to 312.555, which is approximately $312.56. Now, 2,995 at 11% for 1 3/4 years. That leaves us with interest is equal to, PRT and 11% for 1 3/4 years. So 1 3/4 years, 1.75 times 0.11 for 11% times 29.95 gives us 576.5375. So approximately $576.54. That is the amount of interest gained. Right, so let's find the total amount in each account to the nearest cent. Well, total is equal to total equals principal plus interest. So in other words, P plus PRT, which is 250 plus 250 times 4% times 3 years. Well, 4% per year times 3 years. So 250 times 4%, 25 times 4% is 1. 250 times 4% is therefore 10, and times 3. So 250 plus 10 times 3, or 30, is equal to $280. All right then, what about this deposit? Total is equal to P plus PRT. And yes, you can factor out the P and be like P multiplied by 1 plus RT. Times 1 plus 0.06, or 6%, times 2 years. Okay, so 595 times 1 plus 0.12, which means you're dealing with 595 times 1.12. So 1.12 times 595, so that's $666.40. All right then. How about we use 3,600 at 9.1% for 1 3/4 years? Well, total is equal to principal plus principal rate time. So in other words, interest. You can do this before you substitute, instead of doing this factoring and substitution all in one step like I did up there. Like, I'm just showing you guys the details here. So you end up with 3,600 times 1 plus 0.091 times 1 3/4, which leaves us with 3,600 times, 1.75 times 0.091 plus 1 would give us 1.15925. You multiply, and you get $4173.3. Okay then, now let's say we don't want to factor. Total equals P plus I, or P plus PRT. So let's say we don't want to factor. What happens? Then we just do it the straightforward way. 4250 times 4.5% times 3.5. So 0.045 is 4.5% times 3.5, so 3.5 times 4250. You end up with 4250 plus 669.375 plus 4250. You end up with 4919.375. Now, there is a bit of an issue here, guys. We need to round to the nearest cent, which, by the way, also means that, in theory, we should actually have written $280.00 if that's what show to the nearest cent means where you live. But that's not exactly universal when it's whole dollar amounts already. But here, we actually have to round. So 4919.38 approximately. That's the total. Yeah, okay. Well, when dealing with percents and fractions, which are both types of ratios, and decimals, really you only have to deal with one formula, which is that the part divided by the whole is equal to the percent, or fraction. But, well, you remember that the decimal multiplied by 100%, because the decimal is what you're going to get if you do part divided by whole in your calculator. Yeah, you have to multiply by 100% to get the percentage, to convert to percents. So there actually aren't that many formulas. Don't be intimidated by the number of rearrangements that you might be asked to remember, and you'll be fine in general for North American math, because for some reason they like to give us lots of rearrangements. Oh well. So that's it for this chapter. See you next chapter.